I think it's really important to say that it doesn't really matter where an idea comes from. It's really important that cutting-edge ideas are really being fostered. There's really a need for getting them out and giving them the opportunity to show that they may have a very big impact. Dioxide material uses electricity and changes carbon dioxide into carbon monoxide. And LanzaTech has built a lot of its technology around an organism that can eat carbon monoxide. It's really allowing us to develop an ecosystem, an industrial ecosystem, where carbon dioxide is recycled into products that we can then use again in our daily lives.
Dioxide materials is my retirement project. What I was trying to do is to try to do something big for my retirement that would keep me busy for the rest of my life. Well, what we're trying to do is to figure out how to recycle CO2 back to gasoline, to fuels. Nobody had been able to electrolyze CO2 at a reasonable energy density so that they could actually make it commercial. And we used a kind of a co-catalyst to speed up the reaction. People before us had always used two metals as co-catalysts. And what we did is used a metal and an organic species as a co-catalyst, and that had not been done in a significant way before. My machine takes CO2, say from a oil refinery or a coal-fired power plant, converts it into carbon monoxide, and then LanzaTech's process can then take that carbon monoxide and make it into something valuable.
LanzaTech's currently working with dioxide materials in the lab. Dioxide materials has an electrolyzer which takes CO2 and generates a stream of carbon monoxide, which is LanzaTech's microbe's favorite thing to consume. Normally, if you feed our microbe a stream of CO, there's a little bit of CO2 that comes out the back end. We can recycle that CO2 and actually fully capture all CO2 fed to the process. Starting in the lab, working at the test tube scale with these microbes, and also starting with the geneticists who are actually manipulating the DNA of the microbe. The synthetic biologists then pass these engineered microbes to the fermentation team, who does some of the scale-up work and brings it up from the smaller bottles into a 2-liter lab reactor. We then take it as the engineers and turn that lab reactor into a scaled-up commercial-size reactor. So RPE funding, the first phase of the project, took it from that lab reactor into a 30-liter actually circulating reactor. We were able to take that lab pilot of 30 liters and scale it up to the existing 500-liter reactor here in Freedom Pines. We're talking with partners about the next demonstration scale, and hopefully that will take us all the way through to commercial here in the US within the next 5 years.
Rich reached out to us, and when we read what he was proposing, it opened a floodgate of ideas. Because if his technology scales, it would allow us to offer 100% carbon capture into products at any site. In a sense, it's the holy grail. It's kind of a science engineering dream come true. Before it's commercial, you don't know 100% that this is the right journey because you haven't actually done it. But we've done it now. This is the right journey. We have a technology that works. And now we're gonna make that technology work and sing and dance in the best way possible.
It's fun. It's fun to come into the office and work on it. I'm not ready to really retire. The other thing is that I feel I'm doing something that'll save the world.
It is incredibly inspiring to work with people that generate all these new ideas, knowing that I can do a little part to help them along with this work is tremendously inspiring, and I'm very grateful for this opportunity.